So we go from a pretty complex lesson to something rather simplistic. We're going to jump into a new chapter today, and the concept is linear functions, which basically means equations of lines. What we want to know is if we have a linear function, and all linear functions can be written in the form of f of x equals mx plus b, or y equals mx plus b. So if you look at the three equations down below and you want to know if they're linear, instantly you can tell that this function right here is not linear because of the x squared, so that's a no. In this sense, we have both an x and a y in the equation. There's a possibility, since I have an exponent of 1 here and an exponent of 1 here, so I'm going to solve for y. I have 9y equals negative 5x plus 6, divide both sides by y, or by 9, get negative 5/9 x plus 2/3. That's written in the form of y equals mx plus b. So yep, that's linear. In this case, I have exponent of 1, exponent of 1. Let's test it out, solve for y. In this case, I have 2xy equaling a negative 3. In this case, I need to get y by itself, so I'm going to divide by 2x. And since x is in the denominator in this case, that's not written in the form of y equals mx plus b because x is in the numerator. So this again is a no. Good to note, slope of a line is always constant from point to point on a linear function. And therefore, since we're talking about the slope from a point to point on a function, we're talking about the average rate of change, which is also constant. So now let's say you've got a table of data and you want to know if those are linear values. Well, what I want to know, since we just mentioned that the slope is constant from point to point, is look at your x values and y values and calculate your slopes. Let's take a look at calculating the slope here and then calculating the slope here. And if indeed those two slopes are the same, then maybe I want to check a couple of more to see if all those slopes are the same, because it has to be constant from point to point to point. So I'm going to go y2 minus y1 over x2 minus x1. So in this case, for the first point, y2 is 0, y1 is negative 1, so plus 1, over x2, or negative 1, minus 0 is equal to negative 1. To calculate the second slope, y2 is 3 minus y1 of 0 over x2 of negative 2 minus x1 minus a negative 1 is plus 1, and I end up with 3 over negative 1 or negative 3. These two are not equal, therefore not linear. Let's check this second frame right here. We'll call this x, call this y, and we'll find out this slope from point to point and this slope from point to point. Call this m1 and m2 and see if they're the same. So m1 is equal to 4 minus 1 over 8 minus, whoops, I lied, y1, or y2 is 8 minus y1 of 4 over x1 of 2. The other exponent is 1. We end up with 4 over 1. Second slope, first y value is 12. The second y value is 8 over my first x value of 3, the second x value of 2, and then I end up with 4 over 1. And if you look at each jump of 1 results in a jump of 4 every time, so that's a constant slope, so this is linear. So if you want to find out if a function increases or decreases, you just need to check the slope from point to point. And again, we're talking linear functions, because if we were talking a curved function, and if I went from point to point, I could go from this point to this point, and it decreases, whereas if I went from this point to this point, it would be increasing. Right? But this is for a linear function only. So we want to look at our slope. Slope's given by y equals mx plus b. F of x is y. And we know our slope is in front of the x term, so 5 is positive, therefore this increases. In this case, I want to get y by itself, so 4x plus 12 is equal to 7y. Divide by 7, 4 sevenths x plus 12 sevenths equals y. Term in front of the x is the slope, 4 sevenths is positive, therefore this increases as well. Lastly, we're going to answer these two questions. Given the graph to the left, I want to solve g of x equals 20. And I'm wondering, well, what's that mean? G of x, I have no equation for it, but I could certainly find an equation for this line. I know that this line goes through the following point, 1, 2, 3, 4, negative 1, and it goes through the point 1, 1. So if I want to write the equation of this line, I can do that. G of x, or y, equals, I'm going to do a slope here. I go down 2 over 3. So that's negative 2/3 x plus b. And I'm not sure what that is, but I know it goes through the point 1, 1. So I'm going to plug 1 in for y. I get negative 2/3 times 1 plus b. And I can find b. That's just negative 2/3. Add that to the other side. 1 plus 2/3 is equal to 5/3. That's the value of b. So y, or g of x, is equal to negative 2/3 x plus 5/3. Now this initial problem asked me to solve g of x is equal to 20. So the term g of x is equivalent to 20, which is equal to negative 2/3 x plus 5/3. I'll multiply both sides of this equation by 3. Get 60 equals negative 2x plus 5, because the 3's are both going to reduce. I'll then take and subtract 5 to both sides, giving me 55 is equal to negative 2x. So x equals negative 55 over 2. And there's the first problem solved. Next, I want to solve for when f of x is equal to g of x. Well, my g of x equation is right here. My f of x equation I don't have yet, so I'm going to have to go back and solve that. I see f of x being here. I notice this has a negative 2 as a y-intercept, and I know it goes through the point 1, 1, so I can calculate the slope by just counting up 3 over 1. So f of x equals, we just said we had a slope of 3, x, and negative 2 is my y-intercept. Now I want to find out when f of x equals g of x, so I'll set 3x minus 2 equal to negative 2/3 x plus 5/3, because that's g of x. Multiply both sides by 3 and clear my denominator out. That gives me 9x minus 6 is equal to negative 2x plus 5. I have 11x equaling 11. So f of x equals g of x when x equals 1, which we knew anyways because that's where they intersected. Like I said, yesterday was rather difficult. Today much simpler. Fill out the summary, answer the questions on MyMathLab, and I'll see you tomorrow.